Hey everybody. Today I thought we'd do something a little bit different. I thought what we'd do today is a sort of tutorial series on Unity game development, so just real basic stuff. This is something I've been wanting to do for a while. I just haven't found the time. I've been too busy with my own projects. But now I think I've got a few minutes I can sit down and yeah, I wouldn't mind making this little super basic beginner tutorial on how to get started in game development, or just Unity development in particular. If you're interested in game development at all, there's never been a better time to get into it. Game dev is definitely more accessible now than it's ever been, with all the different engine choices out there and all the different resources and all that kind of stuff. There's never been a better time to get into it. So I guess if you're at all interested in it, now would be the time, right? So it becomes, well, what engine do you choose? Do you make your own engine, or how does what do you do there? Spoiler, don't make your own engine. I mean, you can if you're, super baller or whatever. You just really want the challenge. I mean, that's great. But if you just want to make games, I wouldn't waste time trying to make engines. The general sort of wisdom in the industry is make games, not engines, and there's a reason for it. There's lots of super high quality engines out there. And you don't need to feel hamstrung. You don't need to feel, well, what if I want some really specific features? Does this engine support it? Yeah, it does. If you can think of it, you can make it in probably any engine. It's just a matter of being creative with how you do things, right? So don't look at the game engine as sort of a, oh, is it limiting me? It's not. It really isn't. So the question becomes then, okay, well, which engine should you choose? Spoiler, pick Unity. I'm just kidding. You pick whatever you think is most suitable for your own taste or your own project or whatever you're most comfortable with. Me personally, I obviously chose Unity because I wanted to get into 2D game development. I heard at the time that Unity has really great support for 2D, and it does. I can't really speak for Unreal, how its 2D support is. I'd imagine it's perfectly fine. But at any rate, I went with Unity. There's lots of great resources. There's a huge community online. It's super accessible, super easy to learn. So I went with that. So if you're watching this video, I'm guessing, so did you. So what we're going to do in this video is we're going to build out the world's simplest and most boring platform, but I think it's going to be a good sort of starting point to show you the kind of fundamentals of just game design principles and Unity principles and that kind of thing. So we're not going to make it too fancy. And what we're likely going to do is sort of make the basic core structure of this, quote, game, I guess if you want to call it that, in the first video. And then what we'll maybe is just kind of add features at different videos. Like, hey, in video number 2, maybe we'll add some new effects or add the new feature or whatever. We'll just kind of keep building on that. That way we can just keep showing more techniques and things like that as we go and make the game cooler, right? So this tutorial is going to assume that you've already got Unity installed and you've already picked out a code editor. You'll need a script editor. You can use whatever you want. I chose Visual Studio, Microsoft Visual Studio, because it's free, it's very good, it's very powerful, and it integrates nicely with Unity. There's any number of ones you can pick. I mean, hell, you'd even pick Notepad if you really want to, but I wouldn't recommend it. I will go with Visual Studio if you're not sure. So again, we're going to assume that you've already got Unity installed, set up, linked with your code editor, and you've opened a brand new 2D project. We're not going to dive into 3D. There's no real point. I think it's probably best to keep it simple. We'll do everything in 2D right now. So when you open your new project, this is what you're going to be greeted with, basically. So on the left here, we have what's called the hierarchy. And this is all the different game objects in your current scene. Or, you can have multiple scenes in here too. Right now we only have one. It's called sample scene. That's the default name. Under the scene, we only have one single game object, which is our camera, which is this dude right here. And of course, as our project moves forward, it will, of course, we'll add more game objects, characters, and maybe enemies and platforms and things like that. Down here, we have the project tab. This is all the different assets and things in our project. So things like sprites, sounds, pictures, whatever, scripts. Any kind of like physical asset that you need for the game would be stored in here, and you can access it through here and make different folders and stuff like that. So keep it all nice and organized. This next tab over is the console. Since we have some goofy Unity errors here, we'll just clear those out. This is where errors are going to show up, and it's also where debug log statements are going to show up. So in your code, in your scripting, if you want to debug and test things, you can put little statements, say, hey, I'm here in the code, and then it's going to show up in here. It's very useful for debugging. We'll probably go into that a little bit later. On the right hand side, we have the inspector. So what the inspector does is when you click on a game object, it shows you all the different properties of the game object. So we just clicked on our camera here. These are all the different properties of the camera. So we have the camera object itself, and then you have all these sort of components of the camera, right? So the camera has a transform component. We'll go into that later probably. It has a camera component, of course, because it's a camera. And you can see all the different sort of properties of that camera that you can set either in the inspector here or through code if you like. You see it also has an audio listener that just basically sets up kind of like 3D sound, if that makes any sense. Like if your camera's here and there's something making a noise over here, it'll play it more like on your right speaker, if that makes any sense. So it's kind of like audio listener, it's kind of like a 3D sound type thing. It's pretty handy. And of course in the middle right here you have the scene view, which is where you build out your game, where you place all the objects and all that kind of stuff. Versus when you click game, this is the game view. This is what the camera sees. So right now, if we were to play our game, this is what we'd be looking at. We'd be looking at a blue screen. This is just based on the camera color here. You see we could change it to green, but that's really ugly. We're just going to go with blue, and we'll pretend it's a sky. So anyways, that's what that is. This is what the game actually looks like when it would be running. And when you click play to test your game, it'll slip over to this game mode, and you'll be able to see what's going on. Alright, so first things first, as you see here in my assets, I've got a couple of things that I've created in some drawing programs. They're incredibly cheesy. I've got a little platform graphic that I made and a really cheesy, unhappy square character that I made. And basically we're going to have this square character jumping back and forth on some platforms, just to give you the very basic rundown of how stuff works. So first things first, let's go ahead and build our scene. So first we need to add some platforms. So right now, this platform object is just a sprite, okay? It's just a picture, it's a texture 2D, sprite, whatever, alright? So what we're going to do is we're going to drag this onto our scene, and now we have a platform. But it's important to note that you might think, oh look, I have a sprite in my scene. Well, not exactly. You now have a game object. So what it's done here is it's created a new game object in our scene. You see it now, platform? It just kind of went off the name, of course. Platform here, but you see, platform isn't a sprite, it's a game object with a sprite renderer component. So when we dragged that sprite, or that image or whatever, onto the game view, Unity said, okay, you're obviously trying to make a game object with a sprite in it, so I'll just make a game object and set this sprite as its sprite component. So if we look here, if we click on the platform, you can see here, under the sprite renderer component, this is what you need to render the sprite. If we turn that off, it vanishes, see, because now we're not rendering the sprite. So what all it's doing is it's setting this platform sprite that we add to the sprite render component of this game object. So we have a proper full game object here. As you can see, it has a transform component and all that good fun. Now Unity works off a system called prefabs, and these are very, very, very important and very useful. It's one of the most basic fundamental sort of concepts of Unity. The idea of a prefab is you create an object and you set all its different properties and how you want it to work, and then you make a prefab out of it. And that way later on you can easily instantiate new copies of that prefab on the fly as you need to. We're going to right click in the assets folder and go create folder, and we're going to call this prefabs. And now what we're going to do is open that folder, and we're going to actually drag this platform into the prefabs folder. And you see there it makes a prefab of it. And now if you look in the hierarchy window here, you can see that the platform is now blue. So it's changed to blue. That means this object here is based on a prefab. So we're going to need more than one platform, of course. Let's go ahead and add another one. So now that you have prefabs, you can either instantiate them through code, or you can just, at design time, just drag it onto the scene like that. Let's center it a little bit more so it's a little better. Move these in place a little bit. So we're going to have a pretty exciting game here, folks. What we're going to do is we're going to have our character jump from one platform to the next, and that's going to be our game. Pretty exciting, right? So we have our platforms here. Hopefully that's not too far. We'll have to tweak our numbers to make it work, but we'll see. So we have our platforms in the scene. Let's go ahead and make our player objects. Let's go ahead, drag him in. That looks like a decent enough size, I guess. So we have our character in there. Let's go ahead and rename this guy player. We don't need to really make a prefab out of him because there's only going to be one. Right? It's just one player. So we're going to leave that the way it is. So just for the sake of it, if we run our game right now, we're not going to see a whole lot happen. Right now we have our player floating above a platform doing nothing, right? So that's not super exciting. What we want is this player to fall and impact this platform, be able to stand on it properly. So to do that, we need to add something called a rigid body. And what a rigid body does, it's a special kind of component that makes this object, whatever object it's attached to, interact with Unity's built-in physics engine. So what we're going to do is click on our player, we're going to say add component, and then we're going to type rigid body 2D, because we're in 2D, so we'll use the 2D version. The rigid body 2D, and it's got all these settings, most of which you don't really need to worry about right now. The primary one we're concerned with right now is gravity scale. right now, because we've added this rigid body, this object will now interact with gravity at a scale of 1, which is the default amount of gravity. So now that we've done that, let's save, and we're going to run the game again. We'll see what happens. He falls. He falls off the screen and through the platform, which is not what we want, right? So we want him to fall onto the platform. Well, why didn't he impact the platform? Well, there's two reasons for that. First of all, he doesn't have a collider, so the game engine doesn't know where his boundaries are, and also the game engine doesn't know where this platform's boundaries are. So what we can do is we can go into our prefabs, and if we double click on the prefab, we're going to kind of focus in on the actual prefab itself, and then we can make edits to it. And when we edit the prefab in here, what's going to happen is any objects in the scene that are based on this prefab will be updated. The changes will cascade down to all of them. So what we're going to do is we're going to add a component to this, and it's going to be called a box collider. And we're going to use the 2D, of course. So now you see this platform now has, if we edit the collider just to see, you can see this green box. Not sure how well that's going to show up on the video, but this green box is the boundaries of the collision for this object, right? So anytime something touches here, it's gonna trigger a collision, and then the game engine, the physics engine, handles what to do about that next, right? So we now have a box collider on this platform, so we're going to hit and save that. Just save it. We go back out into our scene view. By the way, when you're in your prefab mode, to get out of it, it's this little arrow here right beside the thing, beside the name here. Just click that and you'll go back into your scene view. So now you can see, if we click on both of our platforms, you can see now they have box colliders because we changed the root prefab. But we still have a problem. Right now the player does not have a box collider, so he's still going to fall right through because although they have colliders in the platforms, the player doesn't, right? So we need to add one to him as well. Let's go ahead and do that. There we go. So he now has a box collider, and Unity automatically sets it to the sprite, the smallest square or rectangle that the sprite is, and right now that's perfectly appropriate for us. It's totally fine. So we'll go with that. Go ahead and save it again. I'm a compulsive saver. So now when we click play, we'll see what happens here. See, now he falls onto the platform. It's kind of hard to see. Maybe what we'll do is we'll raise him up a little bit just to really show you the effect here. Boom. He lands on the platform. So now we have our physics set up. Now we just need to add controls. And we're going to do this by adding a script to our player called a character controller. So let's go ahead and select our player. And we will add a component. And we're going to just call new script. And we'll call this player controller or character controller. Yeah. Controller. Okay. And now that's going to appear here. And then we can just kind of double click it to open it up. So this here is our character controller script as seen through Visual Studio. So there's a few components. Now don't be intimidated by scripting. I know that's kind of where a lot of people tend to get tripped up. It's actually not as horrifying as it might seem. So there's a few different sort of components we'll quickly talk about real quick. These three lines up here at the very top of the script, those are called assembly references. So what that means is it's basically saying, okay, for this script, I need to be using a certain collection of, commands and keywords and functions and things, right? So we're using the Unity engine namespace. So all the different specific, functions and things that come with Unity are in there. Same thing with system collections and generic. These are just the sort of basic functions for code that you might use, just the most basic stuff pretty much. So you'll pretty much always have these in your project, so just leave that. And here we have public class character controller mono behavior, and this encompasses all of this. So the quickest thing to look at here, the most important thing is these curly braces. When you see public class something something, or you see void, or you see whatever, these braces are for this guy. This guy here has to do with these. Anything in between these two braces is this guy. Anything in between these two braces is this guy. It's kind of like a hierarchy of braces, if it made sense. It's important to sort of get a hang of that. So you can see both of these methods are within this class, and anything that goes on in here is within this start. Anything that goes on in here is within that update. So that's the first thing you want to sort of pay attention to. So first off, real quick, public class character controller colon mono behavior. What does that mean? Public is the visibility. Public means you can access it from other scripts. Class is the kind of thing this is. We are making a class. The scripts in C# tend to be classes. It's, again, something you can create at runtime. Not super important to worry about right now. Character controller is what we called it. And then colon mono behavior, what does that mean? Colon is inherits from. So this character controller class will inherit all of the behaviors and functions and functionality of a mono behavior. And a mono behavior is a Unity specific data type that they've come up with. So like for like the transform and the rotation, all that stuff we talked about earlier, all these components and that kind of stuff, that's all stored within mono behaviors. So what this is saying is our character controller script is going to automatically inherit all the different functionality of mono behavior without us having to retype it here. So it's just automatically included in. So that's a function, or that's a concept called inheritance, and it's very, very useful. But we won't get into that for this video. Start, as this little comment implies, start is called before the first frame update. So when your game starts, for the very first time, when it starts up, or I guess I should say when this script starts up. So when the object that this script is attached to becomes active, this will start, this will run through code once, and that's it. So it's great for initializing variables and setting things up for the first time before you're ready to go. And then update here, again, as the comment implies, is called once per frame. So this is going to keep running over and over and over and over again. This is your game loop right here. So we'll be needing that for sure. So for our purposes, we're not really going to be needing the start function. We don't really need to initialize anything at the beginning. So we're going to go ahead and get rid of that. And the first thing we need to do is check for user input. So when the user presses something on their keyboard or their joystick or whatever, we want to know about it right away. So what we're going to do is we're going to create a method. So void update, this is a method. We're going to create our own custom method. We're going to call it void check for input. And we're going to open curly braces and close the curly braces to say that, once again, check for input is going to do whatever we put in between those braces is going to execute whenever we call check for input. And what we're going to do actually right here is we're going to actually call it right away. Check for input. So now what's going to happen is in the update function, this is going to run all the time, many times per second, whatever our frame rate happens to be, it's going to keep calling check for input, which of course, again, is anything we put in here. So before we go any further, let's dissect this syntax here a little bit. You see how it says void update. Well, what does void mean? Void is just the return type, and we probably shouldn't get too deep into that just yet. We will probably talk about that in a subsequent video. But it's basically the return type. So if you wanted to make a function that actually spits out an answer, like it calculates something, you would change this to whatever that type would be, right? So if you're calculating a number, maybe you'd use a floating point number or an integer or whatever. Right now, we're not trying to calculate anything. All we're trying to do is just execute lines of code that we put in here. So void just means nothing. You could also say private void or public void, right? And what does that mean? Again, public just means it's accessible from other scripts. Private means it's not. And if you don't specify either way, it assumes it's private. So these are private methods, and that's all they need to be. We don't need to access them from other scripts right now, so we're all good. And you'll also notice that there's brackets at the end of our thing. This is for taking in arguments or parameters, as they're sometimes called. Again, we don't need to get into that. Like if we need to feed in information, like, if we wanted to, I don't know, int x, right? And then we could say x, and you would pass in information if the function needed information. Right now we don't. So we're just going to leave it at that. But that's what that's for. You can send information to the method so it can use that and then spit out the information that it needs to. But right now, again, we don't need to worry about that. I just wanted to show you, so in case you were wondering what all that was. And you'll also notice in C# here, after every line, we want to put a colon, or a semicolon rather. There are exceptions to that, but most of the time you want a semicolon to say, I'm done with this line, so the compiler can move on to the next one. All right, so let's actually check for our input here. So how do we do that? So there's a function called getAccessRaw, and we'll get into that, what that means in a second. So we can use what's called an if statement. So basically, we're going to check if input system dot getAccessRaw. And what axis are we trying to check? We want to check an axis that's called horizontal. And once we're done coding this, I'll show you in a second what exactly that means. But we're checking the horizontal axis. And it's important that you type that exactly like that. It is case sensitive. If the axis raw value is not equal to 0f, then do stuff. Okay. Input is the input system in Unity. Get axis raw is, we're looking to get whatever value the input is receiving on its horizontal axis. So like the joystick, like a thumbstick if you're going left and right, or maybe it's the A and D keys on your keyboard. And those are all actually mapped to this horizontal axis, which I'll show you in a second. This sort of exclamation mark equals 0f. Exclamation mark means not, and equals means equals. So what we're saying is, if get axis raw on the horizontal axis of the input system, if it's not equal to 0f, f means float. I guess just real quick, I might as well show you. Integer would be like 1, 2, 3, 4, just whole numbers. F is a floating point number, so like 2.5. That'd be a floating point number, and you have to put f after that if you're using decimals, and you also have to, make sure you designate it as a float instead of an int. But we're getting off on a bit of a tangent here. So basically, what we're saying is, if the input system's horizontal axis is not equal to 0, in other words, if it's being pressed, because once you press, because it starts at 0 in the middle, and it'll go to -1 to +1. So -1 being all the way left, +1 being all the way right. And if it's 0, it's right in the middle, which means we're not touching the input. So what we're saying, excuse me, what we're saying is, if there is some sort of input on the horizontal axis, well, we need to do something. What we're going to do, if you recall, we put a rigid body component on our character, and this script is attached to that character object. So what we're going to say is, get component, rigid body 2D. So that's that rigid body component that we added. So we want to get that. We want to reference it here. We're going to say add force. Now we're leveraging Unity's physics engine. We're going to add some force. And we're going to create a new vector 2. And that is, we'll go into vectors in a minute. Vector 2, and we want to say input dot, again, get axis raw, horizontal. And then we want to say 0f. And we want to finish that off with a semicolon. So what does this mean? We want to get the rigid body component of whatever object this script is attached to. In this case, it's our player. And we want to add force. Now, what is a vector 2? A vector 2 is a data type that stores an x and a y value, right? So vector 2, and you see we have a comma here. So this is our x value, this is our y value. So we want to add force equal to, on the x-axis, because it's xy, whatever our horizontal value for our get axis raw is, we want to add that much force to the x-axis, and we don't want to add any force at all to the y-axis. Let's go ahead and save that and see what that does. We'll go back into our Unity here, and we're going to play that and see what that does. As I press the A and D keys on my keyboard, the little character moves back and forth. And why does he do that? Well, let's have a look at the input system real quick. That way you have kind of a visual idea of what's happening here. So I believe it's project settings. Here we go. Yeah, input manager. So we have all these different axes, right? Axes. And this is what we were referencing with that whole get axis raw horizontal. Well, you see here, get axis. Oh, look, there's one called horizontal. What is that? Name horizontal, la 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 la. Negative button is left, positive button is right. These are the arrow keys on your keyboard, and you can set that. And then alternate negative button is A and D. So when I press press A, it's actuating the negative. It's sending the input negative on this horizontal axis. And if I was pressing D, it would be positive, which is like +1 kind of thing. Now, because I'm using a keyboard for this, it just goes -1 or +1. There's nothing in between. But if you were setting up a joystick, it would go in between. And there's actually a second, there's a second horizontal here. So right now we have this set up key or mouse button. This is reading input from the keyboard. But if you wanted to set up a joystick, you could just make a second horizontal axis. The axis raw command will access all of the axes that are called horizontal, and you see we have 2 here. So it's going to look at this one too. So this one is joystick axis, right? It's going to look at the x-axis of the joystick. Now on my Xbox One controller for Windows, that happens to be the left stick. So if I was pressing left on my stick right now, it would, or well, when we're playing obviously, it would move between -1 and 1 depending on whether I'm going left or right. Alright, so what's next? Well, next we need to create jumping, because we want to be able to jump from the platform to the next platform. So let's go back into our script and we're going to update our access raw stuff. Well, not our access raw, we're going to update our input system here. So what we're going to do is we're going to add a second condition here. So we're going to say if, and this runs in parallel, they can both happen at once, this get access raw and what we're about to do here. So if we say input.get button down, and that's going to check for keyboard input, or again, it's going to check for, you know, whatever joystick input or whatever. And we're going to say jump. Now if we go back into that system, we'll see there's a jump thing, but we'll come back to that again. If input.getButton.down is jump, so if we're pressing whatever key is mapped to the jump axis, if you want to call it that, then we want to again do something. So again, so we're going to say get component. Again, we're going to access the rigid body 2D of our object, and we're going to put again, we're going to add some force, and we're going to say new vector 2. And we're going to say, this time, we don't want to move on the x-axis when we jump. So we're going to set that to 0f. Remember, it's a float, so you have to put f. And then we're going to say maybe 5. Well, you know, here's what we'll do. Let's be clean about it. We're going to expose a variable here. So we're going to say, we're going to create a new variable. Float, I don't know, jump strength or something, right? Jump strength. So quick aside on variables, just to make that a little bit more clear. So what is a variable? Well, it's a tiny little assignment in the memory of your computer that stores a little bit of data, and the data is variable, hence why they call it a variable. In this case, we've declared a float. Again, a float is a floating point number, which means it's a decimal basically, right? Because the access system of our game here, like the rigid body and the get component and the add force, all this stuff, the vector 2 takes floats. All this stuff takes floats. It doesn't want integers. So we're going to make a float jump strength. But what we're actually going to do is we are going to, well, here, let's just call it here. So we're going to put jump strength down here. So whatever our jump strength is, that's how much force we'll add. But right now we haven't set it to anything. So here's what we could do, but we're not going to. So we could say, we could initialize it equals, I don't know, 20f, I don't even know. We'll have to play with that number and see what works. And this is going to say, okay, so jump strength is now equal to 20. And so when we come down here and we say, you know, get component, blah, 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 add force, jump strength, it's going to add 20 because that's what we've set up here. Oops, I guess I need another bracket there. So, but what we're going to do is something a little bit different. We're not going to initialize it here. What we're going to do is we're going to make this variable public. And that's going to do two things. If you recall, public makes it accessible from other classes, but we don't care about that right now. The other effect this has is it's going to expose this variable in the inspector. So watch what happens. When I click save here, we're going to go back into Unity real quick. And you can see if we give it a second on this character controller script, whoop, now we have jump strength as a variable. We can just set it right here. So if I want to set it to 20, there we go. Now our jump strength is 20. And the advantage of that is you can change this number as you're play testing your game. So you can sort of get a feel for what number is appropriate. So just for the sake of fun, let's go ahead and try that, see what that does. See how much jump strength we actually need. So I press spacebar, which is the jump key, and we'll get into that in a second. You can see him kind of moving, but it's not really doing much. What if we put that to 200? Boink! Now he's got 200 jump strength, which seems sort of appropriate, right? That looks pretty good. Maybe we put it up to 400. That's probably too much. 200 was probably good. What about maybe we'll try 250. Okay, that's a respectable jump, but we have a problem. Watch. Boink, boink, boink. We've got double jump in there, and that's not intentional. So how do we fix that? Before we fix that, let's go back into our project settings. We're going to have a look at jump. So here we see, once again, if get button down equals jump. Well, here's jump right here. What's get button down? Well, positive button is space. So whenever we press space, it's going to access jump. And so that's what we were calling in our code. So again, this is how the Axis system in the input manager in Unity setups. It's pretty handy, pretty useful. But right now we have a double jumping problem. So what we want is we only want this character to jump when he's standing on a platform. There's a way he can't double jump and stuff. And so we're going to leverage our colliders to figure this out. So what we're going to do is we're going to go back into, actually here, one thing I should mention before we do anything, you notice how this is set back to 20? So what's going to happen here is whenever you're playing your game, you can set this number, but when you come out of the game again, it's going to get rid of that information. So if you want to store that properly, you actually want to set this value when your game is not running. So we'll set this back to 250, and now we should be good. Let's go back into our script here. First thing we're going to do is we're going to add another variable to our class here. We're going to call it bool is grounded. Okay. Bool is a Boolean variable, which means true or false. So is grounded basically means, you know, is standing on. It's just meant to mean is he standing on the ground. So this is either true or false. So we're going to initialize it to false. And then what we're going to do is we're going to create a couple of methods, and these are special Unity methods that come with the mono behavior thing. So when we inherited from mono behavior, we were inheriting these cool methods. So we're going to say private, don't have to say private, but void on collision enter 2D. Whoa, what does that mean? So this means that whenever the collider that's attached to the game object that this script is attached to, once again our player character, whenever his collider collides with something else, on collision enter 2D is going to be called. And so when we land on the platform, this will trigger because now our collider has interacted with another collider in the game. So now what we can do in here is we can say is grounded equals true. So now whenever we land on the platform, is grounded will be set to true, because when those two colliders, with the player collider and the platform collider, when they touch each other, this will get called automatically. And so what we want to do is we want to set is grounded to true. So when we hit the ground, is grounded will be set to true. In fact, let's expose this so we can see it as we play. And then what we're going to do is when we jump, we want to get rid of it. So we're going to say once again private void on collision exit 2D. So this does the exact same opposite, thing when they're no longer colliding. This will trigger, and what we want to do here is grounded equals false. Right? So let's go back into our Unity and give that a wee test. And so we're back in our program here. And as you see, he's still double jumping. So why is he doing that? That's because we never checked. That's because we never actually checked if his grounded was activated before we went and jumped. So we can say right here, see we're setting is grounded to false and true, but we're not making any use of it in our jump routine. So if get button down jump, and you'll notice there's two here, two ampersands. So that's important. And so we're going to check two conditions. If get button down is jump and is grounded equals true, then we go ahead and do the jump. Now it's very, very important to note that there's two equal signs here. One equal sign means set this to that. That's what that means. When you have two equal signs, it means you're checking if it is the same as this. So this is a comparison operator, and this is an assignment operator. Sorry, I don't mean to get too complex or weird, but that's a super, super common thing you see people get tripped up on all the time. Comparison operators always have two characters, two things, right? Is not equal, is equal with two, right? And then assignment operators will only have one. All right, so now we're not double jumping. Let's see if we can get over to the next platform. Okay, there we go. Yay. And I think that's pretty much it. I think we pretty well have it. So it's the world's simplest, most boring game, but I think, you know, it was just meant as a really quick intro to how things work in Unity, how the scripting system works, how the basic Unity system works, the basic Unity objects, and all that kind of stuff. Now, what we're going to do, if you guys want to put any particular feature requests in the comments below, anything you want to see how it's done, let me know what you want to see added to this project. Obviously, there's plenty of room to add stuff to this, but if there's anything specifically you want to see how to do, go ahead and just leave a comment, and we'll get to it. In the meantime, I'll probably just think up some real basic weird stuff to add in there just to showcase how things work. But in the meantime, that's gonna be it for now. So we have our little dude getting force. He's not double jumping. He's landing on the platforms with his colliders and his rigid body, and he's affected by gravity. And we have the world's most pointless game. But anyway, there you go. So let me know what you think in the comments below, guys. Anything you want to see again. But for now, I think we're gonna leave it there. So with that, yeah, we'll see you in the next one. Thanks for watching.